All right, I think I can now start with my presentation. Good afternoon. I'm from the Philippines, and the time here it's about 5 p.m. So it's afternoon here. Good day, good morning. The title of our paper is Strengthening Sama Students' Mathematical Resilience through EthnoSTEM-Based Mathematics Instruction in Modular Distance Learning. This is co-authored by Dr. Maria Nympha Joaquin of the University of the Philippines, Diliman. So allow me to introduce our study. Modular distance learning was adapted as a continuity plan, especially in areas with limited access to technology in the Philippines amidst the COVID-19 pandemic. And students from the Sama ethnolinguistic group in the province of Tawi-Tawi had been struggling with learning, especially in mathematics and sciences, during the modular instruction. According to various literature, culturally responsive mathematics pedagogy allows ethnic students to appreciate mathematics in their daily life. And from there, EthnoSTEM transpired, which has the aim of contextualizing science, technology, engineering, and mathematics, or STEM, to overcome helplessness and equip students with skills and attitude to gain success and interest in math. Literature suggested for developing their mathematical resilience. Hence, this study was conducted to develop mathematics modular instruction that integrates culture with STEM to help strengthen the mathematical resilience of Sama students. So what is EthnoSTEM? The researchers defined EthnoSTEM as a culturally responsive approach to STEM for distinct cultural groups of students having four intertwined domains, namely ethnoscience, ethnotechnology, ethnoengineering, and ethnomathematics. And it is important to note that EthnoSTEM is applicable not only to ethnic groups of people, but also to other strata of our society, such as a group of women or a group of researchers like us. So from our review of literature, here's the conceptual framework of our study. There were two modular approaches involved, namely the EthnoSTEM-based, and the other one is the conventional modular approach. And from there, you could see, I think, a array pointing on the mathematical resilience. And this is a construct, according to Kuken 2013, which allows students to develop positive response towards learning mathematics amidst setback. And it has four factors, namely value, struggle, and growth. So from there, we were able to come up with a research question. Do Sama students exposed to EthnoSTEM-based mathematics instruction excuse me, have better mathematical resilience than those exposed to conventional instruction in terms of value, struggle, and growth? For the methodology, the the research design made use of the research design was a true experiment between two groups to examine the effects of the intervention on students' mathematical resilience. And as you can see, this is displayed in table 1 that the experimental group received the EthnoSTEM-based, while the conventional group had the conventional modular instruction. And further, I'm sorry, mathematical resilience scale was given before and after the experiment. So who were the participants of the study? The sample involved 71 grade 7 Sama students from two sections enrolled during the academic year 2020-2021 in a high school in the said province. The 34 students in the experimental group and those 37 in the conventional group were chosen through random sampling based on their previous mathematics grade. The instrument used was a 5-point Likert-type mathematical resilience scale developed by the researchers to measure the mathematical resilience of grade 7 Sama students. A panel of experts validated the test, and it was pilot tested among 253 students for confirmatory factor analysis. Cronbach's alpha was also computed to establish its reliability, which found a 0.89 coefficient representing an acceptable reliability, as you can see in table 2. Let me differentiate the two modular approaches. The conventional approach utilized math learning modules of the Philippine Department of Education with English as a medium of instruction. And as an illustration, as you can see in the slide, the students are asked to group objects according to similarity and later identify if they represent point, line, or plane. On the other hand, EthnoSTEM-based learning modules incorporated EthnoSTEM concepts and ideas found in sama mat weaving and seaweed farming in their mathematics learning modules utilizing their own dialect. And in that particular activity, the students are asked to identify, sketch, and determine measures of some seaweed farming materials, and later classify what concept it represents. There were 5 learning modules developed for the third quarter of grade 7 mathematics. The first one was on points, lines, planes, and angles. And the second one was on line and angle pairs, followed by angles formed by parallel lines, capped by transversal, polygons, and finally, circles. Initially, an ethnography was conducted to determine the ideas and concepts of ethnostem found in seaweed farming and mat weaving in Tawi-Tawi. And based on the ethnographic report, along with the Department of Education learning competencies in mathematics, EthnoSTEM learning modules were developed and presented to Sama mathematics teachers for their comments and suggestions. How did we gather the data? Initially, we sought permission from the school head and consent from the students as well as their parents or guardians. And then the students were assigned to the experimental and the conventional groups through systematic random assignment based on their previous mathematics grades. And after that, a pretest of the scale was administered to both groups. The distribution, discussion, and submission of learning modules spanned for about 6 weeks only due to the school's shortened third quarter. And upon completion of all the learning modules, post-test was administered. Student journals and interview responses were examined to substantiate findings. T-tests were used to analyze and answer the research question of this study. So what did we find? Before the intervention, initial comparability of students' mathematical resilience was examined. As shown in Table 3, independent samples t-test revealed no significant difference in pre-test scores of both groups. Thus, both groups had comparable mathematical resilience prior to the intervention, which can be attributed to the systematic random sampling of students. And after the intervention, effects of the modular instruction on students' mathematical resilience were determined. And as you can see, in Table 4, a one-tailed test showed that students exposed to the EthnoSTEM-based instruction did not acquire significantly higher mathematical resilience score than those taught with the conventional instruction. And this might be due to the limitations of modular learning coupled with a mere 6-week intervention that did not effectively facilitate some students' mathematical resilience. Nevertheless, to further analyze the effects of the intervention on the mathematical resilience, improvement in the pre-test and post-test scores or mean scores within groups was examined. And as revealed in Table 5, there was a significant increase in students' mathematical resilience, particularly on growth factor, but not on value and struggle. And this implies that some students taught with EthnoSTEM were able to augment their belief that they can develop their ability and outlook amidst failures and challenges faced in mathematics. And this is because culture-based mathematics instructional modules could motivate students and enhance their initiatives, as according to Yao in 2016, thereby providing them a path to grow. And based on the journals, indeed, mathematical resilience is not inherent to one's personality and that it can be enhanced and developed. And according to some journals of the students, the EthnoSTEM-based learning modules can capture their enjoyment, motivation, and enthusiasm in mathematics. Based from the findings of the study, it's concluded that EthnoSTEM-based approach can facilitate mathematically resilient behavior, particularly on the mathematical growth among some students. And such improvement in students' mathematical growth manifests that resilience is indeed not inherent to one's personality and that it can be enhanced and developed. Based on the conclusions, the following were the recommendations. First, the ethno-STEM-based instructional approach is highly suggested as an intervention in teaching mathematics to enhance students' resilience, especially on their growth mindset. School administrators should encourage teachers to embrace ethno-STEM in designing learning modules or instructional plans. Teacher education institutions should encourage teacher educators to include ethno-STEM in the discussion of current educational issues and trends. And STEM curriculum planners should introduce ethno-STEM instruction and focus on developing tasks that allow students to create and design outputs. So we're not able to have this in the paper due to some compelling reasons during the COVID-19 pandemic. Finally, for future researchers, they should investigate the effects of ethno-STEM instruction in other contexts or constructs with increased period of intervention. And finally, the researchers wish to acknowledge the Philippine Department of Science and Technology, the University of the Philippines, Diliman, and the Mindanao State University, Tawi-Tawi. Thank you so much for listening, and my apologies for having a sore throat. Thank you.
Thank you very much. Probably now you need to get a glass of water to to quench your throat problem.
Yes, thank you for that.
Okay. Does anybody have a question they want to raise? The audience is quiet, but may I ask a question? So you presented some strong arguments for adopting an ethno-STEM approach. What did you not tell us? What's the downside? What's the problem with this approach?
Okay, thank you for that. The problem is, based on our experience, it took us days or even a month to develop the learning modules, especially if you are not familiar with the culture of that particular society. In a multiculturalist society like here in the Philippines, of course, firstly we should analyze our learners. In my case, it was not that easy to find the concepts and ideas found in seaweed farming and mat weaving, simply because I'm not really familiar with that. But I think if you are really familiar with that particular culture, then it will be easier for you to develop or to find ethno-STEM concepts and ideas and further integrate it to instruction. And that's, I think, one of the downsides of ethno-STEM. It's so difficult to develop the instructional plans, especially if you're not familiar with the culture. Thank you.